So when you have a small oscillation problem, then you have to always keep in mind that force must be linear and potential must be in a harmonic, must be higher order, must be what? Harmonic term. So in general, the matrix method is one of the very fundamental method and you can easily use it. Sometime what you can do, you have to just go for the first principle as we have done into the last class, that you have to just calculate each and every term matrix element with the first principle. Sometime when everywhere you have parabolic term, there is not any functional term, then you have to directly use the matrix method. There is not any problem. But in general, sometime what you can do, you can write the Lagrangian, and after writing the Lagrangian, you can just reduce that all Lagrangian for the form of a small oscillation, for the case of a small oscillation. And once you will reduce it, either you can use the differential equation method or you can directly go for matrix method. So let's go for a step by step for different type of problems. So let's try to do this one. Okay. So today we are just going for the last class of solving problem for small oscillation. So let's try to go for this problem. This is very interesting. So there is one spring and this is mass m. There is another spring and these are rigid support. And this is just moving along x-axis. So this mass m can be moved along x-axis. It has a spring constant k and it has another spring constant k. Second spring has also a spring constant k. And the natural length is L naught. So natural length is L naught. Okay. Both the spring have same natural length. Then what you have to do? How you will solve this problem? So first thing, we have to write the Lagrangian. This is one problem. And then we have to just reduce the Lagrangian for a small oscillation. Okay. So let's see how we can go for it. Obviously, it is constrained to move along x-axis. So what will happen? We can have this sort of situation. I can say this distance is x. So what will be my kinetic energy? My kinetic energy is half m x dot square. This is my kinetic energy. And the main challenge is that how you are going to write the potential energy. So once you are going to write the potential energy, so what is your potential energy? The potential energy will be half k for this particular spring, this distance minus original length. And what is this distance is all about? You can write this distance is root under x square plus L naught square. This is your natural length. This is x square. So you can write this one minus original length. So this will be a square term is there. So this is for the first spring. We have to write it for the second spring, and that will also same thing you have to write half k, and this is x square plus L naught square root under minus L naught x square. So this is your potential energy. So when, and obviously these two things are exactly same. So my Lagrangian of a system is basically half m x dot square minus half, and that will be half will be cancelled out. So that will be 2k x square plus L naught square root under minus L naught whole square. So this is my Lagrangian of a system. So in the examination, they have asked that reduce this Lagrangian for the small oscillation. You have to reduce it for the small oscillation. So this is in general for any value of x. So if we are talking about a small oscillation, what is the meaning of that? Meaning of that, in a kinetic energy, we have to go for the a square term of velocity. We have to see the dimension of a square term of velocity. And in a potential energy, we have to, this will be 2 will multiply, then this will be K something. Okay. This will be K. Sorry. Just check it. Now,
Yes,
for the potential energy, what you have to do? You have to write this potential energy up to order of generalized coordinate square. So what we can do? We can just go for what? Taylor expansion. There is not any need to do the Taylor expansion into kinetic energy. But here we can go for a Taylor expansion in a potential energy because this is in a functional form. So this is in a functional form. So we have to reduce this particular function for the case of a small oscillation. That means we have to go up to which level? We have to go up to harmonic level. So let's try to go for this one. So then we have half m x dot square minus what I can do? I can write this thing as something like I can take L0 square common and I can write 1 plus x by L0 whole square root under minus 1 whole square. Now we can go for the Taylor expansion, isn't it?
yes, sir.
हम टेलर एक्सपेंशन में जाएंगे इसे and we have to keep the term up to square term, isn't it? So if we are going for this particular Taylor expansion, then what you will get? You will get half m x dot square minus k L naught whole square. So if we are going for this particular Taylor expansion, then 1 plus 1 upon 2 and x naught upon L naught whole square. The first term itself will be square term, isn't it?
Yes, sir.
So there is no need to go for the further term. So we are just going up to first term because it is just giving you that x square term. And higher order term can be neglected. Minus 1 is there, but 1 square is there. And due to this square, this problem will be again become very complicated. Why it will become very complicated? Let me first calculate all this thing. So if we are going to write this particular Lagrangian, then this value is half m x dot square minus k L naught square into 1 by 4, and this will be x4 to the L naught to the power 4, isn't it?
Yes, sir.
And when you are going to solve this particular problem, and you can just go for L naught square, and then you can see this can be written as, I am just using this space actually. So this can be written as L is equal to half m x dot square minus 1 by 4 x to the power 4 upon L naught square, isn't it? So even if we are doing the Taylor expansion up to square term, is that, sorry?
K will also come.
K will also come. Yes, thank you. K will also come. Okay. Now look at here. Up to we are doing the Taylor expansion up to square term. Even if we are doing the correct thing, is that this will execute a small oscillation or simple harmonic motion? Is that it will execute the simple harmonic motion?
No, sir.
No, sir.
No, why not? Why not?
Because
It's in
potential
fourth order.
Yes, it is fourth order, and when you will go for the equation of motion, that is d upon dt del L upon del x dot minus del L upon del x must be equal to 0. Then you have mx double dot plus kx to the power cube upon L naught square. 4 will cancel out, must be equal to 0. And listen, the dimension is up to a square. Dimension is exactly matching with the half kx square, isn't it? Length to the power 4 by length square is something like length square, isn't it? But variable is up to x4, and you can see x double dot is proportional to minus x cube. So this is not a harmonic. This is unharmonic term. Are you getting my point?
Yes,
And
sir.
this equation is not a linear equation. Unless until you are not getting the linear equation, you cannot find the angular frequency as your constant. Obviously, most of the people have done my stability analysis class or phase curve. सारे बच्चे किए हुए हैं ना? Just tell me.
Yes, sir.
है ना? And where we have done this particular action angle principle, हम लोगों ने किया है? Say yes या no? अगर आप में से किसी ने नहीं किया है, then please let me know. I will do it extra classes for that. Okay? Because it's very important because every year there is one question will be there. Okay?
मेरा नहीं हुआ
Okay.
नहीं हुआ सर मेरा।
अच्छा, जिनका भी नहीं हुआ है, just tell your name to the Satish sir. Okay? Just message him. I will take one extra classes for that. But other people, I think they have done this particular action angle principle when we have done the phase space, isn't it?
Yes, sir.
Okay, don't worry. So now you can see x double dot is proportional to minus x cube, and this is not a harmonic. The acceleration must be proportional to minus x. Then only we can write omega is equal to something k upon m, and k must be some value, isn't it? So look at the problem is very simple, one-dimensional problem, but this is not exactly giving the answer of your this particular one spring mass system. This is something more complicated to do, isn't it? So what you have to do? So what is the idea? Idea is that first you will write the Lagrangian of a system in a very natural way. And after writing the Lagrangian of a system, if you want to go for the small oscillation, then you have to go for the Taylor expansion up to square term. And once you are doing the Taylor expansion after a square term, then only you can decide whether it is just equivalent to harmonic oscillator or it is not equivalent to harmonic oscillator. Yes, it is also oscillatory system. It is also oscillatory system, but it is not a harmonic oscillator, equivalent harmonic oscillator. Okay? Restoring force is there, bounded motion is there, but force is proportional to minus x cube, which is non-linear in nature. ठीक है?
Yes, sir.
Okay. Now, let's go for simple pendulum. Let's go for simple pendulum. If we have simple pendulum, this is mass m, this is length L, this angle is theta, and this is in x and this is y. Here is the direction of gravity. What will be Lagrangian of simple pendulum? That will be half m L square theta dot square plus mgl cos theta. Okay. Now, if you are going for the simple pendulum, for the case of simple pendulum, and for the simple pendulum, if you are going to write the equation of motion, then what will be equation of motion? D upon dt del L upon del theta dot minus del L upon del theta must be equal to 0, and that value is equal to ml square theta double dot plus mgl sine theta is equal to 0. And now you can see this is a equation of motion, and this equation of motion is not so simple. Are you able to solve it directly?
No, sir.
No, you cannot able to solve it directly. When you are very simply, you can solve it. When you are assuming theta is so small that you can write your sine theta as equivalent to theta, that means you are just going for the Taylor expansion, and this Taylor expansion can be written as theta cube by factorial 3 plus theta 5 by factorial 5. Is that I am writing correct Taylor expansion for this?
Yes, sir.
है ना? Okay.
Yes, sir.
So this is your Taylor expansion. And now, when you are taking this particular Taylor expansion, if you are assuming theta cube is significant, then again you have nonlinear term, isn't it?
Yes, sir.
If you are assuming theta cube is significant, it is not so small comparison to theta 5, then obviously this is not your significant term. But if you are assuming that theta cube is very small, then only you can write sine theta is equal to theta by assuming theta cube or theta square is very small. So when you are assuming theta square is very small or theta cube is very small, so sine theta double dot g upon L theta can be equal to 0, and in the Taylor expansion of sine theta, these all term is not so significant for you. Then only your simple pendulum will behaving like a small oscillation, and its angular frequency omega is nothing but g upon L. Otherwise, this omega can be different value. This is a very primitive level of approximation कि at least चलो इतना तो हम कर लें. You can do it for the Lagrangian also. So when you are approximating the functional form in a force equation, in a Newton's law of motion, then the force must be linear. But when you are just going for the energy part, then obviously you have to go for parabolic equation. Suppose someone will ask you, write down the Lagrangian for small oscillation for simple pendulum. What you will do? How you will approximate it? Are you able to approximate to this one? No. There is not any functional form. Your kinetic energy is itself functional of theta dot square. But here you have to go for a approximation. So what will be Taylor expansion of cos theta?
1 minus
theta square by 2 factorial.
1 minus theta square by factorial 2. And next term is what? Plus
Plus theta 4
theta 4 by factorial 4. And what is your assumption here? What is your assumption here for the small oscillation?
Up to theta square.
Yes, you have to take the significant term up to theta square, and you assume theta 4 is very small. When you are assuming theta 4 is very small, then you can have your Lagrangian for a small oscillation, and that value is half m L square theta dot square minus you have mgl theta square by factorial 2 and plus mgl. And this is your constant term, nothing to do with the equation of motion. When you are going for the equation of motion, let's see what is going to happen. Just we are using equation of motion. What you will get? ml square theta double dot plus mgl theta must be equal to 0, and that will give you exactly same equation of motion what you are approximating either in force or in potential. Is that clear?
Yes, sir.
So जब भी आप potential में जा रहे हो, sometimes you can say this is a functional form. This is given in a functional form. So there is no other option that you have to go either for equation of motion and you have to go for the Taylor expansion, and you have to do this Taylor expansion in a very efficient manner. Efficient manner means you have to always take care of square term when you are going for the expansion for either Lagrangian or Hamiltonian. But if you are doing the approximation in an equation of motion, then obviously you have to go for what? Linear term after doing Taylor expansion. Everyone is comfortable?
Yes, sir.
Okay, so let's try to go for moving pendulum. यहाँ तक क्लियर है ना? ये सारे क्वेश्चंस आएंगे आपके एग्जाम में डिफरेंट फॉर्म में. Okay, so always be prepared for the new question. But if your fundamental is good, then you can attempt new question. Always think in a classical mechanics and quantum mechanics, the examiner will ask new question because this is just a application of your theory. Okay? So
Yes, sir.
always try to use your fundamental knowledge to solve the problem. ठीक है? Again we will come to the small oscillation when we will go for rotational and all other thing. ठीक है?
क्वेश्चन कैसे पूछा जाएगा ये?
क्या बोल रहे हो?
क्वेश्चन कैसे पूछा जाएगा कि
हाँ, क्वेश्चन पूछा जाएगा कि भाई सिंपल पेंडुलम के लिए, जैसे अभी तो सिंपल पेंडुलम का तो आंसर आपको पता है. ये मैं आपको इसलिए बता रहा हूं क्योंकि आपको कॉन्फिडेंस गेन हो. ओके, अब आपसे ये पूछा जाएगा कि चलो ये सिंपल पेंडुलम है, फॉर द स्मॉल ऑसिलेशन और हार्मोनिक, फॉर द स्मॉल ऑसिलेशन व्हाट विल बी एंगुलर फ्रीक्वेंसी. दिस इज द वन ऑफ द बेस्ट क्वेश्चन यू हैव एवर आस्क्ड. ठीक है, अभी जैसे कि नेक्स्ट क्वेश्चन देखते हैं. मैं कॉम्प्लिकेशन लेकर आ रहा हूं, अभी मैंने कॉम्प्लिकेशन नहीं लेकर आया है. ठीक है, अभी मैं वही चीजें कर रहा हूं जो आपको पता है. ठीक है, लेट्स ट्राई टू कम टू द नेक्स्ट. जो दो क्वेश्चन हम लोग सॉल्व करेंगे, यू विल इजिली फाइंड there is complication and you have to use your technique of Taylor expansion in a very efficient manner. This is very important. Okay, तो जब भी स्मॉल ऑसिलेशन की बात हो, दिमाग के अंदर क्या आना चाहिए? दिमाग के अंदर यह आना चाहिए कि अगर मैं लैग्रेंजियन में अप्रोक्सीमेट कर रहा हूं या कर रही हूं, तो हमें किस लेवल तक जाओगे? स्क्वायर टर्म तक जाओगे. और अगर मैं इक्वेशन ऑफ मोशन में अप्रोक्सीमेट कर रहा हूं, तो किस लेवल तक जाओगे? लीनियर टर्म तक जाओगे. यस. और कई बार यह भी होगा कि जैसे कि फर्स्ट क्वेश्चन जो मैंने किया था कि आप तो टेलर एक्सपेंशन स्क्वायर टर्म तक गए थे, लेकिन आपको मिला क्या? फोर्थ ऑर्डर का टर्म मिल गया. तो उस समय आप कुछ नहीं कर सकते हो. यू हैव टू यूज डिफरेंट थ्योरी, यू हैव टू यूज नॉन लीनियर डायनेमिक्स टू एक्सप्लेन दिस टाइप ऑफ प्रॉब्लम्स. ओके.
Yes.
अब सपोज करो ये प्रॉब्लम हम लोगों ने लिखा था, कर लिया है इसका हम लोगों ने. दिस इज योर मास m1 and this is your mass m2 and this is moving in x direction and this will be angle theta and this is my origin, this is my x distance. ये तो हम लोगों ने कर लिया है ना. This is what? Moving pendulum. ठीक है.
Yes, sir.
एंड दोनों ही. तो इसका लैग्रेंजियन क्या था? हाफ m1 x डॉट स्क्वायर. ये तो फ्री पार्टिकल की तरह बिहेव करेगा, है ना. सेकेंड वाले का क्या था? हाफ m2 x1 डॉट स्क्वायर प्लस l स्क्वायर थीटा डॉट स्क्वायर. और क्या था?
2L theta dot.
Plus 2L.
टू टाइम था ना. 2 टाइम x डॉट l थीटा डॉट एंड cos थीटा,
Cos theta.
है ना. So this will be your cos theta. And what is your potential energy?
MGL cos theta.
So minus minus plus mgl cos theta. अब देखो ये प्रॉब्लम को हम लोग करने की कोशिश करते हैं for the, and now what we have to do, we have to find the equation of, sorry, we have to find the angular frequency of m2. Look at कितना कॉम्प्लिकेशंस होने जा रहा है, आपको समझ में भी आएगा और किस तरह से आपको इंटेलिजेंटली चीजों को सॉल्व करना है. ठीक है. सो मैं ऐसा करता हूं कि ओके, दिस इज माय लैग्रेंजियन ऑफ अ सिस्टम. व्हाट वी हैव टू डू, वी हैव टू जस्ट राइट द इक्वेशन ऑफ मोशन or we have to just find the angular frequency omega for a small oscillation. Now you can see this problem has a most toughest part of a physics. What is that one? What is
Cross
that
term.
one? Huh?
Cross term.
Cross term, this term, x dot and theta dot, coupling term. So whenever you have coupling term, the equation of motion of first term can be written as a, sorry, the equation of motion of one coordinate have function of another coordinate, isn't it? ये होना ही होना है.
Yes, sir.
Okay. अगर ये cos theta का term नहीं होता, then life will be very easy. Suppose ये cos theta का term नहीं होता, then life will be very easy, isn't it? x1 हटा देता हूं, x ही रहने देता है ना. So suppose this cos theta term will be not there, then life will be very easy, isn't it?
Yes, sir.
Why it will be very easy? Even if there is cross term, life will be very easy. Why?
The
Expansion.
whole square term.
Obviously, every term has a square term, and you can easily use matrix method. है ना?
Yes.
You can easily use matrix method. But due to this cos term, this cos theta in a kinetic energy, it is very difficult to go for it. है ना? So what you have to do? You have to first approximate your kinetic energy as well as your potential energy for a small oscillation. Now, let's try to go for potential energy. What is your potential energy? That is what? Minus mgl cos theta. This is your potential energy, isn't it? Now, for the small oscillation, what will be that potential energy? Minus mgl 1 plus or minus?
Minus.
Minus theta square by factorial 2. And we can easily write this thing as mgl theta square by factorial 2 minus mgl. Don't worry. Constant term has nothing to do with the force. That will not make your life tough. This term is actually a square term. Now, let's go for the kinetic energy part. So when we are going for the kinetic energy part, then we have half m1 x dot square plus half m2 x dot square plus l square theta dot square plus 2 x dot l theta dot cos theta. And now my mathematics tell us that, okay, if you are expanding it up to square term, you have to expand it up to square term, isn't it?
Yes, sir.
And when you are going to expand it up to square term, then what will happen? Suppose we are going to expand it into square term, then what is going to happen?
सर मैं डायरेक्टली टर्म मिल जा रहा है.
First term is okay with you, but second term have theta square as well as theta dot as well as x dot. So when you will go for the equation of motion, it will create a havoc. This is very important, because if it is going to multiply with this, and when you are just going to multiply this thing with this particular theta square, and then you will go for the equation of motion, you will just get very, very clumsy equation. So we will do a very crude approximation. Very crude approximation. What we will, and what is logic behind that? Is that this term is a dimension of velocity square? Say yes or no?
X dot square. Yes.
Yes. Is that this term is also velocity square?
Yes, sir.
Is that this term is also velocity square?
Yes, sir.
Yes.
Yes, sir.
Is that this term is also velocity square?
Yes, sir.
Velocity into L theta dot is velocity. And velocity into velocity is velocity square. And if this term is up to velocity square, and what is approximation into kinetic energy? What is kinetic energy matrix? The kinetic energy matrix is the coefficient of eta I dot, eta j dot, isn't it? This is
Yes, sir.
coefficient of Tij is nothing but the coefficient of half eta I dot, eta j dot. So onto that logic, what we can do in a kinetic energy, we can approximate this cos theta as 1. There is no other option to us. We can approximate this cos theta as 1, and then you can see that your life is very simple. So what is the rule? When you are approximating for the kinetic energy, then what you will do? You will just try to see up to square term. Okay, and all other term you can just neglect it. So here you can see the cos theta term I am using 1 minus theta square. Sorry, for the potential energy, cos theta term I am using 1 minus theta square by 2. But in a kinetic energy, we are using this cos theta is approximately equal to 1. And now, what is my approximated Lagrangian? The approximated Lagrangian is half m1 x dot square plus half m2 x dot square plus L square theta dot square plus 2 x dot L theta dot, and this is my kinetic energy, and we can go for potential energy also. And what is my potential energy? Is minus mgl theta square by 2 plus mgl. And now we have to solve the equation of motion. So let's try to solve the equation of motion. And again, you will see the difficulties is there. And you can see theta is just a cyclic coordinate. Sorry, x is just a cyclic coordinate, isn't it?
M2GL होगा ना?
M2GL, M2GL, M2GL. Okay. And this is also M2GL. Okay. And now you can see, is that x is your cyclic coordinate?
Yes.
Sir.
X is cyclic coordinate. So if x is cyclic coordinate, there is no need to write the equation of motion in x direction. You can just see del L upon del x dot is equal to something like px, and which must be constant. And what is your px? And this constant is equal to m1 x dot plus m2 x dot, and you have plus m2 L theta dot is equal to constant. Now you are very lucky that you have this term, because it will help you to solve the equation of motion completely. So let's try to go for writing the equation of motion in a theta term. So this will be del L upon del theta minus del L upon del theta must be equal to 0. Now look at what will happen. The first term will be, sorry, dt. This will be dt. Sorry, this is theta dot. What will be first term? So you have d upon dt ml square theta dot. Here you have also theta dot, but x dot is also there, isn't it?
Yes, sir.
So what you have? 2 and 2 will cancel, and this will be m2 plus m2 L x dot is there. And now del L upon del theta, there is not any term in theta here. You have to just go for this. So you have plus m2 GL theta must be equal to 0. And now when you are going to solve this particular equation, that value is m2 L square theta dot or theta double dot plus M2 L X double dot plus M2 GL theta must be equal to 0. Now, how you will solve it?
Sir, by substitution from the above
Yes, you
equation?
can use this one. Hence, it is constant. You can write X double dot is equal to M2 L theta double dot by M1 plus M2 with the negative sign. Isn't it? And you can see when you will put it here, then theta double dot is proportional to theta. And that is case of small oscillation, isn't it?
Yes, sir.
यहां से आप नहीं कह सकते ना, because you have to convert it into theta double dot. Yes?
Yes, sir.
So once you are going to convert it into theta double dot, then oh sorry, मैंने मिटा दिया. So let's try to go for it. What will be my x double dot? क्या आया था? Minus m2 theta double dot by m1 plus m2. यही था ना? Now we
Yes,
will
sir.
put it here.
2L theta double dot.
क्या?
एक L भी है.
L भी है. Okay, good. So now we will put it here. M2 L square theta double dot plus M2 L. Take minus sign here. You have M2 theta double dot and L is also there by M1 plus M2, and you have plus M2GL theta must be equal to 0. And when you will multiply it, then which term will survive? Only M1 term will survive, isn't it? अगर इसको मैं यहां मल्टीप्लाई करता हूं तो
Yes, sir.
होगा ना? So what will happen? M1 L square theta double dot by M1 plus M2 plus M2 GL theta must be equal to 0. Am I correct?
Sir, M1
M1
M2 भी.
और M2 भी रहेगा ना? M1 M2 भी रहेगा. Yes, M2 will also there. So now you can take M2 common. L square you can also take common. So I think you will get theta double dot plus G upon L, and you have M1 plus M2 by M1 theta must be equal to 0. And what is your omega? Your omega is root under G upon L, something like harmonic oscillate, sorry, something like simple pendulum for a small oscillation. And this is 1 plus M2 by M1. Yes? And now you can argue with me at this particular point of time कि सर आपने ये जो किया है तो आपको ऐसा लग रहा है कि आपको आंसर पता है इसलिए आपने ऐसा किया है. Because I have just keep cos theta is equal to 1 minus theta square in potential energy, and same cos theta as 1.
Yes, sir.
It is very crude. I have just told you just when I started this particular problem, yes, this is a very crude approximation, but even if it is crude approximation, it will give you the correct result. How we can judge my result is correct or not? How you can convert this problem into a simple pendulum? What is difference between simple pendulum and this particular linear pendulum?
Sir, we
M1
can put
fixed.
M1 in silent.
Yes, this M1 will become fixed. You can fix this particular M1. And when you are going to fix this M1, what is meaning of that? When you are going to fix this M1, that means you can take M1 tends to infinity. And when you are taking M1 tends to infinity, that will be actually root under G upon L. Isn't it?
Yes, sir.
हो रहा है क्या? Look at. So why, in spite of this is very crude approximation, we can go for this type of approximation because our theory is so refined that in a kinetic energy, we have to go up to velocity square, and in a potential energy, we have to go for the generalized coordinate square. Everyone is comfortable? And you can expect this type of problem because after qualifying this particular exam, you will go into research field. And when you will go into research field, what you have to do? You have to solve the complex problem. Maybe there is not any complete solution for that particular problem, but you have to, in a more or less cases, you have to give the at least approximated solution. And your approximated solution is correct or not, if you are just comparing it with the ideal situation, such as here, we are comparing it with the ideal situation of the simple pendulum, we are getting the exact result. So your research can be accepted. I know it is very difficult to sync, but even if it is very difficult to sync, you have to make a formulation that how you can approach this particular problem. Clear है ये? और अगर आप किसी तरह से आपने cos थीटा यहां पर 1 माइनस थीटा स्क्वायर बाई 2 ले लिया और ट्राई करो उसे सॉल्व करने की, इट विल क्रिएट हैवॉक टू यू. जस्ट ट्राई इट. अभी तक एग्जाम का डेट भी नहीं निकला है, तो आप ट्राई कर सकते हो एक बार. देखो क्या होता है, कैसा प्रॉब्लम आता है. You will find this x dot and theta dot is very difficult to decouple. Okay? Okay.
Yes,
So let's go for a final problem, that is a double pendulum. So I will just give you the Lagrangian, and after that you will use the matrix method and you can solve it. Here I am not using matrix method. Why? Because I have potential energy only function of theta square. So actually this is something like one dimensional matrix. So this equation of motion is just a one dimensional thing. So when one dimensional thing is there, it is not good to use matrix method. Obviously we will use matrix method when at least 2 or more degree of freedom is there, isn't it?
sir.
Because x is itself cyclic coordinate. So if x is cyclic coordinate, then obviously only theta part will contribute for the oscillatory system. है ना? And this problem also asked into your this particular tutorials. So you can just solve this one with yourself. I will just give you a hint. Okay. So this is your double pendulum of mass m1, and this is your double pendulum of mass m2. Okay, and you can take m1 and m2 same, such that calculation can be easy. So take m1 and m2 same. So this is your L1, this is your L2. So you have to solve the problem for m1 is equal to m2 is equal to m, L1 is equal to L2 is equal to L. You have to find the omega. Okay, this is your homework. You have to calculate it. Okay, but actual thing I will discuss here. So what is Lagrangian for? First I will write Lagrangian for m1 and m2. So what is your kinetic energy?
Sir, half.
So you have generalized coordinate. ये सारा आपको पता होगा. This is theta 1 and this is your theta 2.
Double.
So half m1 L1 square theta 1 dot square. Okay.
Yes, sir.
Second one, half
M2.
m2 L1 square theta 1 dot square plus L2 square theta 2 dot square. And is that any cross term?
Yes.
Yes.
Two
So
times
2
L1,
L1 L2 theta 1 dot theta 2 dot cos θ1 minus θ2. Okay, यही तो था ना?
Yes, sir.
And what is your potential energy?
So minus m1 g L1 cos theta.
Very good. So potential energy, you can see this is minus m1g L1 cos theta and minus m2g L1 cos theta plus L2 cos theta 2. यही था ना?
Yes, sir.
Okay. Now this is your kinetic energy, this is your potential energy. So let's try to first go for potential energy for a small oscillation. What you will do? यहाँ क्या करोगे? Cos theta की क्या ले वैल्यू?
So 1 minus theta square.
Very good. So this is 1g L1, 1 minus this is theta 1. So theta 1 square by factorial 2. Higher order term we can neglect here. Here m2g, what is this term? क्या लोगे यहाँ पर? 1 minus theta 1 square factorial 2 और यहाँ पर क्या है?
L1.
L1. And here is L2, 1 minus theta 2 square by 2. Okay?
Yes, sir.
So this will be the kinetic energy. Obviously, this will not contribute into this m2g is not going to contribute into your force, this constant term, because constant potential has nothing to do with force. So your potential energy is approximately, if I am neglecting this constant term also, then potential energy is approximately, what will happen? m1g L1 theta 1 square by 2 plus m1g L1 theta 1, sorry, m2g, no? So this is m2g L1 theta 2 square by 2 plus m2g L2 theta 2 square by 2. And now you can see this potential energy is a diagonal term or non-diagonal term?
A diagonal term.
Diagonal.
Diagonal term, you can see. And you can add it also, don't worry. But you have to solve for m1 is equal to m2 is equal to m and L1 is equal to L2 is equal to L, so that you can easily solve the matrix. Otherwise, it will be very difficult or it will complicate. Unnecessary complications will be there. We have to focus on concept. Look at this is first time you are saying that your potential energy is what? Diagonal potential energy, isn't it?
Yes.
Yes, sir.
And now you can just go for the kinetic energy. What should be your approximation? Are you able to do some approximation here?
No, sir.
No. This is all about my favorite velocity square. This is also velocity square. L theta dot square is velocity square. What about this one?
Velocity square.
Velocity square. Is that this one is also velocity square?
Yes, sir.
Yes.
Yes, sir.
So what I have to do? I can assume this term is equal to 1. And now when you will go for the kinetic energy term, you can see the kinetic energy term will not a diagonal term. Is that it is diagonal term?
No, sir.
No, due to this theta 1 dot and theta 2 dot, it is not a diagonal term. So what you have to do? You have to just write the kinetic energy matrix, just write the potential energy matrix and solve the determinant and solve the secular equation. You can get the omega. So this is your tutorial problem. Try to solve with yourself. Okay. Only from this problem, you can just go for step by step, each and everything, and you can solve this one. Okay.
Yes, sir.
Okay.
Yes,
हाँ.
sir. Sir, it means जब भी हम लोग को ऐसा कोई टर्म मिलेगा cos थीटा का, हमारी कोशिश यही रहेगी कि काइनेटिक एनर्जी को हम लोग डॉट के टर्म्स में लेके आए, राइट?
Obviously.
ओके।
Obviously. देखो हमारे पास कोई ऑप्शन नहीं है ना.
यस सर.
आर यू गेटिंग? हमें तो सॉल्यूशन चाहिए ना. हम तो चाहेंगे कि हम बिना अप्रोक्सीमेट किए हुए सारा चीज निकालें. ये हमारी
Yes, sir.
फर्स्ट चॉइस होगी.
यस सर।
जैसे मैं तुम्हें दिखाता हूं, हम लोग क्लास को कंक्लूड कर रहे हैं। सो हम अब क्या करना चाह रहे हैं, जस्ट हमें क्या करना चाहिए और हमको क्या करना पड़ता है वो हम देख रहे हैं। यहां तक क्लियर है ना?
यस सर।
जैसे फर्स्ट प्रॉब्लम सपोज करो ये तुमने क्लास 12 में किया होगा। क्या था ये? दिस इज के एंड दिस इज मास m। इस प्रॉब्लम को जब तुमने सॉल्व किया था तो हमने कंप्लीटली सॉल्व किया था ना? देयर इज नॉट एनी अप्रोक्सीमेशन। यस या नो?
यस सर।
यस। अब अगर इसके बाद हम लोग मूव करते हैं सिंपल पेंडुलम में, तो सिंपल पेंडुलम के साथ अच्छी बात यह थी कि जब आपने इसे सॉल्व किया ml² थीटा डबल डॉट प्लस mgl साइन थीटा इज इक्वल टू 0, तो क्या आप इसे सॉल्व कर पा रहे थे?
नो सर।
नहीं कर पा रहे थे। तो आपने बोला चलो यार एटलीस्ट इस लेवल पर तो इसे ये तो बना दे किसी तरह। आर यू गेटिंग माई पॉइंट और नॉट?
यस सर।
अब इसे ये बनाने में आपको सिर्फ पोटेंशियल एनर्जी को ही अप्रोक्सीमेट करना पड़ा था। यस, एंड दिस इज ऑल्सो वेरी क्रूड अप्रोक्सीमेशन, that you are just writing sin theta is equal to theta. It will depends what is your theta and what is its significant value. अगर आप बहुत ही प्रिसाइज आंसर चाहते हो तो sin theta की वैल्यू थीटा लिखने से काम थोड़ी चलेगा।
राइट सर।
You have to go for sin theta is equal to theta minus theta cube by factorial cube, है ना, factorial 3, and after then you have to go for at least 3 term. अब ये आपको डिसाइड करना है कि आप कहां पर सिंपल पेंडुलम को लेकर काम कर रहे हो। ऑब्वियसली इन अ मैकेनिकल सिस्टम वी कैन टेक दिस थीटा, और हमारे पास कोई ऑप्शन नहीं है, देयर इज नो अदर ऑप्शन। सो चलो यहां पर हमने क्या किया भाई, साइन थीटा को थीटा किया और इस प्रॉब्लम को इसके रूप में लिख दिया, है ना। टेक m इज इक्वल टू 1, l इज इक्वल टू 1, आपका सेम इक्वेशन आ जाएगा। यहां भी आप m इज इक्वल टू 1 ले लो, k इज इक्वल टू 1 ले लो। क्या आ जा रहा है आपका x डबल डॉट प्लस x इज इक्वल टू 0 एंड थीटा डबल डॉट प्लस थीटा इज इक्वल टू 0। So this is the most natural simple harmonic motion, most natural harmonic oscillation or system. Simple pendulum is not a natural. It will behave something like this when you approximate theta is equal to very small. अब इस सिंपल पेंडुलम के बाद आपके पास सिस्टम आ गया जो आपने ग्रेजुएशन और मास्टर्स में कर रहे हो, ये मूविंग पेंडुलम। अब इसे भी हमें क्या करना होगा, हमें इसे किसकी तरह बिहेव करवाना होगा, इसी की तरह तो बिहेव करवाना होगा ना।
यस सर।
अब इसकी तरह बिहेव करवाने के लिए जो जो अप्रोक्सीमेशन करना पड़ेगा हम वो सारे करेंगे।
यस सर।
एवरीवन इज कंफर्टेबल?
Yes, sir.
So our idea is that whenever someone is asking for the harmonic oscillator or small oscillation, then my equation of motion must be something like this. Assume all parameter is equal to 1. So आपको किसी ना किसी तरह से उस इक्वेशन ऑफ मोशन को कैसा लिखना पड़ेगा, इसी फॉर्म में लिखने की कोशिश करना है। अब उसके लिए जो भी आपको अप्रोक्सीमेशन करना है आप करोगे। तो यहां पर हमें क्या अप्रोक्सीमेशन करना पड़ा, हमें यहां पर ब्लंट अप्रोक्सीमेशन करना पड़ा। पोटेंशियल एनर्जी में हम लोगों ने cos थीटा को क्या कर लिया, 1 माइनस थीटा स्क्वायर बाई 2 कर लिया, और काइनेटिक एनर्जी में cos थीटा को 1 ही कर दिया, है ना। बिकॉज अगर हम वो नहीं करते तो इस फॉर्म में चीजें आ ही नहीं सकती है, और नहीं आ सकती तो हमारे पास सॉल्यूशन नहीं होगा। ठीक है ना। सो ऑब्वियसली यू हैव टू जस्ट गो फॉर दिस वन। नाउ एक और मैं, सो लेट्स गो फॉर वन मोर प्रॉब्लम, जस्ट अ वेरी सिंपल वन। अगर आपको कुछ इस तरह के फंक्शंस पोटेंशियल दे दिए रहा है तो क्या करोगे? So we are just on the concluding mark, है ना? सपोज कोई भी सिस्टम है, उस सिस्टम में डिफरेंट टाइप के पोटेंशियल हो सकते हैं. सपोज हमारा पोटेंशियल है कुछ इस तरह से. सपोज ऐसा पोटेंशियल और आपसे कह रहा है कि भाई ये स्मॉल ऑसिलेशन करेगा, क्या करोगे आप?
हाँ सर, इसको अप्रोक्सीमेट करेंगे.
ऑब्वियसली यू विल जस्ट गो फॉर द टेलर एक्सपेंशन. और किस ऑर्डर तक लेकर जाने की कोशिश करोगे?
सेकंड ऑर्डर.
सेकंड ऑर्डर तक लेकर के जाने की कोशिश करोगे. ठीक है. और उसमें जो लीनियर टर्म रहेगा वो कैंसिल हो जाए तो अच्छी बात है. नहीं कैंसिल हो तो वो आपको बहुत ज्यादा कुछ नहीं कर सकता है. फोर्स के साथ एक लीनियर टर्म आता जाएगा, है ना? सो अगर फोर्स के साथ कुछ सपोज पोटेंशियल में कुछ लीनियर टर्म भी आ जाए तो उसको कैसे आप चेंज कर सकते हो? सपोज पोटेंशियल एनर्जी में कुछ ऐसा आ जाए, लैम्डा एक्स स्क्वायर प्लस अल्फा एक्स, ऐसा आ जाए तो क्या कर सकते हो? अगर इस तरह का पोटेंशियल आ जाए तो
हाँ सर, इसमें कंप्लीट कर लेंगे स्क्वायर को.
यस, व्हाट यू विल डू, यू विल मेक इट परफेक्ट स्क्वायर, है ना? आप परफेक्ट स्क्वायर कैसे बनाओगे? आप इसे लिख दोगे एक्स एक्स स्क्वायर प्लस अल्फा बाई लैम्डा एक्स, और यहां पर क्या कर सकते हैं? 2 से
अल्फा
मल्टीप्लाई
लेते
कर सकते हैं, 2 से डिवाइड कर सकते हैं. सो क्या हो जाएगा? अल्फा बाई 2 लैम्डा का होल स्क्वायर माइनस अल्फा बाई 2 लैम्डा होल स्क्वायर. ऐसा कर सकते हैं.
यस सर.
एंड व्हाट यू हैव लैम्डा एक्स प्लस अल्फा बाई 2 लैम्डा होल स्क्वायर, यही होगा ना?
यस सर.
माइनस, सॉरी 2 लैम्डा, सो माइनस अल्फा स्क्वायर बाई 2 लैम्डा. ये लैम्डा इसके साथ आ जाएगा. नाउ दिस इज योर परफेक्ट स्क्वायर, इजंट इट? ये फिर से हार्मोनिक ऑसिलेटर हो गया, है ना?
Yes, sir.
Are you getting my
Yes, sir.
point? This is again become harmonic oscillator and it is constant term. Constant term is nothing to do with your thing. ये सिर्फ एनर्जी को ऊपर नीचे में फोर्स के लिए कोई भी काम नहीं करेगा. सिर्फ आपका क्या चेंज होगा?
Situation of motion.
मीन पोजीशन चेंज होगा, है ना?
Yes, sir.
Sir.
मीन पोजीशन चेंज हो जाएगा. यहां पर मीन पोजीशन क्या हो गया? माइनस अल्फा
Minus
बाई 2
alpha
लैम्डा
by
के
2.
अबाउट वो ऑसिलेट करेगा. इक्विलिब्रियम पॉइंट चेंज हो जा रहा है. यस,
Yes.
Yes.
है ना? तो लेकिन अगर कुछ ऐसा आ जाए एक्स क्यूब, तब आप क्या करोगे?
तब कुछ नहीं कर पाएंगे सर.
कुछ नहीं कर पाओगे आप, है ना? आइदर आपको इसे जीरो करना पड़ेगा, इसे अप्रोक्सीमेट करना पड़ेगा, तो ये कुछ कर सकते हो, या तो फिर आप फिर उस फॉर्म में जाओ ओमेगा को स्मॉल ऑसिलेशन करने के लिए. क्या करोगे? यू हैव टू जस्ट गो फॉर डी स्क्वायर वी अपॉन डी एक्स स्क्वायर, एक्स इज इक्वल टू एक्स नॉट, सॉरी ओमेगा बाई एम. उस फॉर्म में जाकर के आप चीजों को सॉल्व कर सकते हो, है ना?
यस सर.
भाई किसी भी पोटेंशियल को स्मॉल ऑसिलेशन के लिए हम अप्रोक्सीमेट कर ही सकते हैं. हमने तो क्लास यहीं से शुरू किया ना,
यस सर. यस सर.
है ना? सो ऑलवेज अपने दिमाग को ओपन रखिए. और ये चैप्टर मोस्ट इंपॉर्टेंट चैप्टर है. इसलिए ये चैप्टर इंपॉर्टेंट है कि ये कहीं भी यूज किया जा सकता है. अभी देखोगे हम लोग अब कुछ और प्रॉब्लम करेंगे. जब हम लोग रोटेशनल फिनिश करेंगे तो फिर से स्मॉल ऑसिलेशन का कैसे, मोमेंट ऑफ इनर्शिया का रूल क्या हो जाता है, बाकी सारी चीजें कैसे आ सकती है, दैट थिंग विल बी कम इनटू पिक्चर, है ना?
यस सर.
Okay, so I think I must stop this class here. So just you can do it also. इसके लिए भी पोटेंशियल एनर्जी मैट्रिक्स लिख लो, है ना? V मैट्रिक्स फॉर्म में लिखिए. दिस इज योर होमवर्क, ओके? बट दिस होमवर्क इज नेसेसरी, है ना? ये आप सारे लोगों को करना है. ओके,
Okay, sir. Yes,
ठीक
sir.
है. So hope you people are ready for test.
Yes, sir.
Okay. Last test दिया.
Poisson bracket वाला.
हाँ.
Yes, sir.
क्या रहा? मार्क्स कितने परसेंट आए?
Sir, अभी 90 है.
90%.
Yes, sir.
गुड, वेरी गुड, वेरी गुड, एक्सेलेंट. तो अब उसमें आपको ज्यादा सोचने की जरूरत नहीं है. ठीक है. दूसरे टॉपिक को तैयार कीजिए.
Yes, sir.
प्रीमियम की मैं बात कर रहा हूँ. प्रीमियम क्लास टेस्ट की बात कर रहा हूँ.
नहीं सर, अभी प्रीमियम नहीं दिया है.
नो, आई एम जस्ट टॉकिंग अबाउट प्रीमियम.
ओके ओके सर.
क्लास टेस्ट में मुझे कुछ लेना देना नहीं है, क्योंकि क्लास टेस्ट के क्वेश्चंस मोर और लेस बुकलेट के क्वेश्चंस को टेस्ट फॉर्म में दिए हुए हैं. ठीक है.
अच्छा. यस सर.
ओके. आई एम ओनली कंसर्न अबाउट प्रीमियम. प्रीमियम टेस्ट कितने बच्चों ने दिया है? बताइए. सतीश सर ने तो ग्रुप में
हाँ
सेंड
सर,
भी किया था ना.
मतलब शेयर हो गया सर, देना है. उसमें सर टॉपिक्स का एक्चुअली खुला है, मैंने तो सोच रहा था कि ऑसिलेशन कंप्लीट होके एक साथ दो.
नहीं, ऑसिलेशन का तो अलग है. ऑसिलेशन की तो अलग है. उसमें ऑसिलेशन
ओके.
कहाँ है? नहीं है. आप देखो, टॉपिक का नाम देखो उसमें. देखो उसमें क्या टॉपिक है. आपके पास है वो?
हाँ सर, ओपन कर रहा सर.
देखिए. देखो, अगर क्लास के साथ साथ आप अगर इस टेस्ट पर पूरी तरह से रिलाई करोगे, देन दिस इज मोर देन एनफ फॉर यू. इससे ज्यादा कोई नहीं कर पाएगा. लुक एट दिस इज प्रीमियम CT6 जनरलाइज्ड कोऑर्डिनेट लैग्रेंजियन हैमिल्टोनियन फॉर्मुलेशन कैनोनिकल ट्रांसफॉर्मेशन पॉइजो ब्रैकेट जेनरेटिंग फंक्शन. ओके.
ओके सर. सर इसमें नॉइथर्स थ्योरम भी एक.
नॉइदर थ्योरम ठीक है. उसकी चीजें हम लोग कर लेंगे कहीं से भी.
ओके
ठीक
सर.
है ना.
ओके सर. यस सर.
उसकी उतनी खास जरूरत नहीं पड़ रही है ना.
जी सर.
एनीवे, नॉइदर थ्योरम के थ्रू आप कंजर्वेशन प्रिंसिपल ही जानते हो, तो हम लोग पॉइजो ब्रैकेट का यूज करके कर लेते हैं, है ना.
जी सर.
तो अभी तक सारे प्रॉब्लम उसके थ्रू हो जा रहे
ओके सर.
हैं. ओके.
यस सर.
ठीक है. सो प्लीज टेस्ट जरूर दीजिए. अगर आप टेस्ट नहीं दे रहे हैं तो फिर प्रॉब्लम में फंसेंगे. ठीक है.
ओके
चलो.
सर.
ओके.
थैंक यू सर.
ओके.
Thank you, sir.
थैंक यू.